So for DC motor interfacing, we require pulse width modulation. With the help of pulse width modulation, we can vary the speed for DC motor as per the variable time period which is specified by your PWM. Now here the problem statement is given to interface DC motor with PIC18, calculate 40% duty cycle to run motor for a given PWM period frequency 4 kHz. The system frequency for PIC18 is applied as 48 MHz oscillator frequency with prescale value for prescaler timer is 60. Now whatever the PWM calculations are required for the calculation of your varying pulse width modulation, 6 different steps are used. In very first step, you need to jot it down for system frequency. Here, as per this problem statement, 48 MHz is the system frequency. So FOSC is equals to 48 MHz. As per this frequency, we need to calculate system period for it. So in order to calculate this TOSC, it will be evaluated on the basis of 1 upon 48 MHz, which is nothing but 20.83 nanosecond. In third step, as per the frequency is given in the problem statement as a PWM frequency, we need to calculate PWM period. So write it down PWM frequency, and as per that frequency, we need to calculate the PWM period for that frequency. So which is nothing but 1 upon 4 kilohertz, that is 250 microseconds. In the problem statement, if at all prescaler value is given, take that timer to prescaler value. If not, then we need to assume as per the data sheet and as per the requirement for the timer too. So here in this problem statement, prescaler value is given as a 16. So we need to calculate in 6 step is PR2. Now PR2 is equals to given in the case of PWM period upon 4 multiplied by TOSC multiplied by TMR2 prescaler value, everything minus of 1. So after putting all those values all together for calculation of your PR2, we need to calculate, we will able to generate this particular PR2. So this particular value we need to convert it into hex, and this will be considered as a PR2 value to get loaded in the PWM. In pulse width modulation, as a CCP module is used, so 10-bit resolution output will be there. So as per that 10-bit, the CCP2 is multiplexed with the port B and port C data latch. So the appropriate trist bit must be used to clear and make the CCP2 pin as an output pin. And in last step, we need to calculate duty cycle. As per this particular problem statement, we need to evaluate duty cycle for 40% duty cycle. So this is the duty cycle formula, and here the PWM period will be of 10-bit size. So 10-bit is the resolution for PWM, and in order to that, lower 2 bits will be mentioned in the CCP1 con register, and remaining bits will be maybe the 8 bits will be mentioned in CCPR1L register. So again, 40% duty cycle, 40 multiplied by 48 megahertz, which is nothing but system frequency, upon 100 multiplied by PWM frequency, which is nothing but 4 kilohertz, and timer prescaler is 60. After calculation, we need to able to get the respected decimal value into hexadecimal number. And as this 10-bit resolution will be there, we need to place this 10-bit resolution 2 bits in CCP1 con register, 8 bits in CCPR1L register. So in order to that, we need to convert this particular hexadecimal value into the binary, and likewise the binary answer, lower 2 bits will be placed in these two bits of the CCP1 con register, and remaining bits will be placed in CCP1 PR1L register. So this is interfacing diagram for DC motor interfacing. So here PIC18 F4550 is connected with the motor. Now here the motor itself will be the DC motor, and we need to have driver circuitry. So here this is LM293D driver circuitry, which is attached with the DC motor. So as this motor will be operated at 12 volts, so we need to have this particular driver circuitry to run this motor separately as per the separate power supply of 12 volt. Whereas in for this 8051, which is operated at 5 volts, so in order to that to run this motor, we need to give extra supply to this motor. Now, as per this configuration of LM293D driver, at a time, two motors can be connected to it. So individually to run that respected motor, enable signals are there, and input signals are there, so that you can connect and run your motor, maybe in the case of forward direction or reverse direction. When you put this particular pin as a high, and when you put this pin as a low, in that manner motor will run in forward direction. When you put these two bits as a 0 0, means your motor will be in off, 1 1 condition will be invalid, and 0 1 condition will be considered as a reverse direction rotation for your motor. Now in order to that, here the one of the enabling bit will be connected to RC2, which is nothing but here which will help you to get the turn on this particular motor, and RC6 and RC7, where you have given this particular input channel for this LM293D driver circuitry, so that your output will get executed on the out 3 and out 4 of this motor. Now algorithm while using this particular PWM will be for DC motor interfacing. First we need to set the PWM period by using PR2 resistor. So as per the calculation, whatever value you will able to get it from this particular PR2, that we need to set it in the PWM period resistor, which is nothing but very first. In second step, in order to have the calculation for the respected duty cycle, in problem statement as per that 40% duty cycle is calculated. So as per that we need to set the 10-bit PWM resolution will be set in the case of lowest 2 bits will be in CCP1 con register, and remaining 8 bits will be loaded in CCP1 PR1L register. After that, we need to as we wanted to enable this in the case of CCP1, so we need to make this particular CCP1 pin as an output pin by clearing this particular trace register. After that, to turn on the motor, maybe in the forward direction or reverse direction, we need to monitor this particular RC6 and RC7. In the configuration for forward direction, it has to be 1 and 0. So like that way, your motor will be turned on. After that, timer to prescale value, we need to enable this particular timer to, because as PWM is nothing but one of the particular functioning ability under the CCP module, and for the CCP module, that too within PWM mode, only timer 2 will help you out. So for that purpose, set the timer to settings. In order to that, as per the timer, it will all the time will compare the value of your PWM period with the timer period specified by your system clock. Like that way, your timer will get able to turn the particular time period as per the requirement of 40% duty cycle, or whatever the duty cycle is mentioned into it. And after that, we will configure this PWM operation with respect to the CCP1 module. So using this algorithm, we can start writing the code for it. So very first thing you need to mention is header file and pragma setting. So these two are nothing but header inclusion as well as pragma settings for executing the hardware for that purpose. As per the algorithm, we need to first set the direction. So motor is connected to 6 and 7. So for that purpose, we need to use the trace register as RC6 and RC7. These two bits are used. That's why RC6 and RC7 bits are used with the output direction. And like that way, you will able to set again the C2, which is nothing but enable pin for your LM293D driver circuitry to run that respected motor, which is connected via one of the channel using LM293D. So we need to set that particular direction. After that, as per the algorithm, we need to set the PWM period. No, calculation is given as per the requirement is for 4 kilohertz PWM period, PR2 value is evaluated as BA, hexadecimal value BA. And for this particular setting, so as per the duty cycle, we need to set the 10-bit resolution in CCPR1L register, which is nothing but 4C, and CCP1 con register with the 0x3C. So this 0x3C is nothing but not only to enable the CCP module under PWM mode, but also to load these two bits which are derived from the duty cycle. These two bits has to get loaded in the CCP1 con register in the form of DCB0 and DCB1. Like that way, if you put all these together, then you will able to came across with CCP1 con register as 0x3C. After that, to enable the timer with the 16-bit prescaler, T2 con register is loaded with 0x07. Then to turn on the motor in forward bias, we need to place RC6 as a 1 and RC7 as a 0. Then and then only your motor will be rotated in forward direction. If at all this will be placed as a 0 and this bit will be placed as a 1, then the motor must be rotated in reverse direction. When both of the bits are 0, 0, then as I have told you earlier, motor will be in stop condition and 1, 1 state for these two bits will be invalid. So in that manner, this respected condition for so to execute this PWM DC motor interfacing, go to your MPLAB project wizard. Click on to the next and select the device. So PIC18F4550 device is selected. Click on next. In that, select the active tool suite as a C18 microchip C18 tool suite, under which we have to consider, as we are writing this as a C code, that's why MPLAB C18 C compiler, we need to select this. After that, click on next. Now here you need to create a project name. In order to that, you need to assign this in the respect of one respected folder will be there, under which you will be able to have this particular PWM testing. So here is the path for which I am saving the particular project file under one folder, and click on next and finish. Once you finish with it, now we need to add source file. So for which for this purpose we need to collect a new file. So under this new file, we'll be saving this file under this particular project as a source. So we'll be selecting C source file with file name as a PWM with extension .c. We need to add this particular source file to the project. So click a particular this option, add file to the project and save. Once you save that, this particular source file will be enlisted in the source file category. Now here you can write that same code which we have just now discussed. So as per the 40% duty cycle and 4 kilohertz PWM period, we supposed to write this particular code. After that, we need to build this option. After the successful building, the condition of failed and unfailed, as per the, if at all some kind of errors are there, we need to resolve all those errors, and like that way we'll be able to generate executable file. Once executable file will be generated, click on programmer. Make sure that your PIC18 is connected with your hardware, and select this particular programmer as a PIC18. Once you select that, we will be able to write this particular hex code onto the hardware.
For DC motor interfacing, we require DC motor. So here the DC motor is there. So one, for the rotation purpose, one wheel is connected to it. So through that you can see the direction and speed for that motor. This motor will operate at 12 volt. So we require 12 volt supply. This is 12 volt supply. Again, this supply will be common for your motor as well as PIC18. So for this purpose, what you have to do is, initially here you have to change this jumper setting. So this jumper wire at JP1, you have to connect it to the external supply, so EXT. So you have to connect from 1 and 2 pin, you have to short using this jumper. So meaning of this is nothing but you are simply changing the external supply. So short pin number 1 and 2 for this JP1 jumper. If at all it is from USB, then you have to short it from 2 and 3. So right now we are using this external supply, not as a USB supply. So that's why we have taken here as 1 and 2 are short. PIC18 is required, this 12 volt supply and DC motor. One FRC cable, because we are connecting this DC motor using this on this particular port C. So here is your motor driver. So this LM23D motor driver circuitry is there, where 2 channels have given. So you can connect it to this channel or to this channel. So at a time 2 motors you can run using this. So this motor driver is given in this DC motor section. So we are connecting it from one of the port and making it to this respected driver circuitry, and from driver circuitry you are connecting to the DC motor. Once you successfully download that executable file using PIC18 and MPLAB, just provide reset. The output will be displayed on DC motor. You have to turn on supply and you have to reset. We can controlling it using PWM. If you carefully observe, as and when we are changing the P rate, this effect on it, the speed is getting changed. So like this way we can have the variable speed for this DC motor using PWM.